Now let's start with the 41st question. Two conducting circular loops of radii r1 and r2 are placed in the same plane with their centers coinciding. If R1 is greater than R2, the mutual inductance M between them will be directly proportional to. Now, let's say that there are two loops like this, and the radius of the first loop is R1, and the radius of the second loop is R2. Now, obviously, this greater than R1 is greater than R2. Now, let's say there is a current I1 flowing through the bigger loop. Now, what is the magnetic field generated at point O? Magnetic field due to a closed circular current carrying loop is mu naught I by 2R. Now, since this radius is very small, R2 is very small, magnetic field at almost all the points on the second loop is almost the same. So the flux through the second loop due to the current in the first loop can be written as magnetic field at O multiply by area of the second loop, which means pi r2 square. So the value becomes mu naught I by 2 r1 times pi r2 square. We can rearrange these terms to make it mu naught by r2 square by 2 r1 times I. Now we can say that flux through 2 is proportional to current through 1, and the proportionality constant is taken as the mutual inductance. So this is the value of mutual inductance, and we can say that it is proportional to R2 square divided by R1. R2 square divided by R1. So the correct option is the third option. All right. Now let's come to the 42nd question. Now, three resistors are having a resistance R1, R2, and R3 are connected as shown in the given circuit. The ratio I3 divided by R1, I3 divided by R1 in terms of the resistances used in the circuit is. Now, since I1 is divided among R2 and R3 in the ratio of 1 by R2 and 1 by R3. So this becomes R3 by R. Now, using componendo and dividendo technique, what we can say is I2 divided by I2 plus I3 is equals to R3 divided by R3 plus R2, and basically I2 plus I3 gives I1. So the value of I2 by I1 is this much. Now what if we have to find the value of I3 by I1? See, the value of I3 by I2 is R2 by R3, and similarly I3 divided by I3 plus I2 is equals to R2 divided by R2 plus R3. Now this is the value of I3 by I1. So this becomes R2 by R2 plus R3. So the correct option is the first option. All right. Let's come to the 43rd question. In the product F is equals to Q equals B, B is given like this. And for Q is equals to 1, V is equal to this much. Force acting is this much. You have to find the value of B. Now, what we need to do, we need to simply find the cross product. Q value is 1, and now V cross V is calculated using determinant technique. And this is equal to now let us evaluate this. The component of I becomes 4. So from here, comparing the I, J, and K components, we can say minus 2b is equals to 12, which means b is equals to minus 6. Now, if we put in the value of b as minus 6, from here we can get 4b naught minus 6 times minus 6 is equals to 4. So 4b naught is equals to minus 32. So the value of b naught is minus 8. So the value of magnetic field over here is the fourth option, because the value of b is minus 8 and the value of b naught is minus 6. All right. Now let's come to the 44th question. 27 drops of same size are charged at 220 volt each. They combine to form a bigger drop. Calculate the potential of the bigger drop. Now let's say the original potential is V naught and that is equal to 220 volts. Now there are 27 drops of the same size that are charged to the 220 volts. Now this is equals to K Q by R. So the value of Q becomes V naught R by K. Let's say this is the first equation. Now, since 27 drops combine to form a single drop, we apply volume conservation. Volume initial is equal to volume final, which means 27 times 4 by 3 pi r cube gives 4 by 3 pi r dash cube. So the value of r dash becomes equal to 3r. Let's call this equation number 2. Now I have to calculate the potential of the bigger drop. Obviously, V dash is equals to K into 27 times the charge, because the equivalent drop has a charge of 27Q, divided by R dash. So this becomes K times 27Q divided by 3R, which basically means 9 KQ by R, which means 9 V naught. So this becomes equal to 9 times V naught, which means 9 times 220 volts. So now if we calculate this value, we will get an answer of 1980 volts. So the correct option is the third option. All right, let's come to the 45th question. A ball of mass 0.15 kg is dropped from a height of 10 meter. It strikes the ground and rebounds to a same height. The magnitude of impulse imparted to the ball is. The first thing that is given is it rebounds to the same height, which means that the initial velocity of the ball is the same as the final velocity of the ball. So basically, initial velocity is equals to minus uj cap, and the final velocity is plus uj cap. So initial momentum is equals to minus muj cap, and final momentum is plus muj cap. So the change in momentum is 2 muj cap. And this is the impulse that is acting on the ball. Now, what is the value of u? It is equals to under root 2gh. All right. Now, let's put in this value. 2 times 0.15 times under root 2 into 10 into 10. That basically becomes 3 root 2. Now the value of root 2 is 1.4. This becomes 4.2. So the correct option is the first option. Let's come to the 46th question. A car starts from rest and accelerates at 5 meters per second square. Now at t is equal to 4 seconds, a ball is dropped out of the window by a person sitting in the car. Now obviously at the end of 4 seconds, v is equals to u plus at. So the speed of car is 20 meter per second towards the right. So the car would be moving towards right with a velocity of 20 meters per second. Now, if the ball is dropped out of window, obviously its acceleration would be equal to g, that is equal to 10 meter per second square. Now, after 2 more seconds, that is at 4 plus 2, that is 6 seconds. Obviously, its velocity will be equal to 0 plus g times 2, which means 20 meter per second in the j direction, minus j direction. And obviously it would have an initial velocity of 20 meter per second in the I direction. So what will be the velocity of the ball? That will be equal to 20 I cap minus 20 j cap. Now if we take the magnitude of this value, this will be under root of 20 square plus minus 20 square. Now this will come out to be 20 root 2 meter per second. And obviously the acceleration would be 10 meter per second square. So the correct option is the third option. All right, third option. Let's come to the 47th question. A point object is placed at a distance of 60 centimeter from a convex lens of focal length 30 centimeter. Now let us draw a lens. Now since this is object and this is 60 centimeter, that is 2f, its image will definitely be formed at 60 centimeters. This much we know about the convex lens. This is the image. Now there's another mirror kept at the 40 centimeter from the lens. Now this image will act as the object for the second reflection from the mirror, and obviously its image will be formed at 20 centimeter. Let's call this I2, and it will be formed at 20 centimeter in front of the plane mirror, since this distance will be equal to this distance. All right, now this is not it. The light rays continue to move to the convex lens, and again they are going to form an image. Let us consider the third image. Now for the third image, I2 will be acting as the object. This direction is acting as the positive direction, this direction acting as the negative direction. So the value of u will become minus 20 centimeters from the lens. The value of focal length is given in the question as plus 30 centimeter. Now let's apply the lens maker formula. 1 by v minus 1 by u is equal to 1 by f. So from here we solve, and this value will become 1 by minus 1 by 60, which means the value of v will become minus 60 centimeters. All right. So the value of v is minus 60, which means that the final image is formed at 60 centimeters from the lens, and it is in the minus direction, which means over here. So obviously it is located at a distance of, see, this is 40, so this will be 20 centimeter from the mirror, and it will definitely be a virtual image because light rays are not actually intersecting, they are projected backwards. All right, so correct option is the third option. Now let's come to the 48th question. From a circular ring of mass m and radius r, an arc corresponding to 90-degree sector is removed. This is arc. Okay. The moment of inertia of the remaining part of the ring about an axis passing through the center of the ring and perpendicular to the plane of the ring is L times mr square. then the radius of K is. All right. Now, if you remove a 90-degree sector from a circular part like this, if you remove this, only this much is remaining. Now, the mass of this is 3m/4. Obviously, the moment of inertia about O would become 3m/4 mass times radius square, which means 3/4 multiplied by m mass square. So the value of K is 3/4. So from here we get that the fourth option is the correct option. All right, let's come to the 49th question. A uniform conducting wire of length 12A and resistance R is wound up. This is not wound, this is wound up as a current carrying coil in the shape of an equilateral triangle of side A. Now, if 12A length is wire is wound in form of an equilateral triangle, obviously AAA is the parameter. So there has to be 4 turns to it. Now, similarly, if it is wound in the form of a square of side length A, obviously it would have total number of turns as 3. All right. So N is equals to 3 over here. Now, what is the value of dipole moments? All right. Dipole moment formula is NIA, which means 4 times I. So this becomes I A square. Now, in the second case, this becomes NIA, which basically means 3IA square. So obviously, the fourth option seems to be the correct option. All right, let's come to the 49th question. Sorry, 50th question. A particle of mass and is projected with a velocity of KE square from the surface of the Earth, where VE is the escape velocity. The maximum height above the surface reached by the particle is. Now, what we can understand is that if a particle is thrown from here, the increase in the GPE, let's say it has traveled a height h, and let's say this is the radius of the Earth. So the increase in the GPE is given as mgh divided by 1 plus h by r. And obviously, whole of the kinetic energy is converted into GPE. So what we can write is half k into velocity square. That is half m into velocity square, because this is the kinetic energy decrement, is equal to change in the gravitational potential energy, which is equals to mg h divided by 1 plus h by r. Now let us solve this. The value of small g is written as gm by r square. And the value of escape velocity can be written as, see, it is escape velocity square, right? So it is written as 2 gm by r square. All right. Now, once we try to find this value, this is what we have to find. We have to find the height. So the value of height becomes k square r divided by, see, k square divided by 1 minus k square. And r can be written over here. All right. So this is our correct option, which makes this third option as the correct option. All right. Thanks a lot for this discussion. I hope you have understood all the questions. Again, thanks from Narayana, Delhi, by your